Now it's time for the our next speaker, Professor Carlos Pérez del Pulgar from University of Málaga, who is going to present the activities of the Space Robotics Lab in University of Málaga. Thank you very much.
Okay. Thank you, Miguel. Thank you, Miguel and David, for the organization of this workshop. My name is Carlos Pérez del Pulgar. I'm an associate professor at the University of Málaga. This is the picture of our faculty. This is the biggest faculty here in Málaga. We have more than 4,000 students here. And our lab is within this building. Also, we are hiring people, PhD students and also postdocs, but we are a very modest university with a very modest lab. And I would like to talk about our city, about Málaga. Málaga is located in the south of Spain, in Andalusia, in the Andalusian region. It has 500,000 habitats in winter, but in summer it's 3 times, 1.5 million habitants. It is because all the people want to go to Málaga to go to the beach and spend the summer there. And also we have quite famous people such as Picasso and Antonio Banderas. And a lot of people think that Antonio Banderas is from Mexico, but not. Antonio Banderas is from Málaga. It is because of the Zorro films, but he's from Málaga. Even he's currently living there, and you can see him walking around the city center sometimes. Well, also the best of Málaga is the average temperature, the very good weather, almost 33 degrees. It's quite good city to spend all the year. There are people going to the beach all the year. We have more than 160 kilometers of beaches, and also we have very good food and very good sweet wines. Well, related to our modest lab, I am the responsible of the Space Robotics Lab. It started in 2016 with the signature of the first contract with the European Space Agency, and that was related to how to increase autonomy in planetary exploration rovers. Our lab is some kind of a spin-off lab from the System Engineering and Automation Research Group from the University of Málaga. It has more than 30 years doing research, firstly at the beginning in agriculture, using robots for agriculture, providing the first robot that was used in greenhouses in the south of Spain, in Almeria also. And right now they are working on, say, search and rescue tasks. That's the reason we founded the Space Robotics Lab to be focused especially on planetary exploration as a extreme environment. Well, related to the mission of our lab, the first mission is to research novel methods to solve issues related to space robotics. We are trying to research how we can increase, for example, autonomy in planetary exploration rovers. Also trying to move technology from Earth to space and vice versa. For example, if we are getting good results in planetary exploration, how we can move these technologies that are already developed to the Earth. Also, as a lab within a university, our mission is to train future engineers in the field of space robots. Every year, more than 10 students spend some time working in our lab and collaborating in our activities. Also, we are collaborating with different research institutions in joint projects. For example, we are collaborating in international projects through the European Space Agency and also in European projects you will see later. And also we are providing some kind of technology transfer to industry with different contracts with some industrial companies. Our main collaboration, the first one is with the European Space Agency with different activities, but also training some engineers from the European Space Agency. We have been supervising 2 PhD students from the European Space Agency. Also, we have a very close collaboration with the FKI that have been presented here, some results. We recently signed a memorandum of understanding with the University of Bremen to perform a joint supervised PhD. Right now we have 1 student involved in that. And the main advantage of it is the PhD student could get the PhD title from the University of Málaga and also from the University of Bremen at the same time. And finally, we have industrial activities, mainly with a Spanish company, GMB. We have been participating in different activities with them, doing this technology transfer. And also, finally, we have a joint research unit with the Andalusian Institute for Astrophysics. In this case, we are collaborating with them in the robotization of telescope, but it will require another presentation for it, and I'm not going to talk about it anymore in the presentation. Well, related to the main objectives of our lab, we can see here in this diagram, in this figure, we started working on path planning, how we could increase and optimize the way we are planning the path to reach a goal from an initial position. And once we were working on that, we realized that we will need to enrich the information that is provided to the path planner using some kind of advanced sensor that I will show you later, increasing the rover navigation capabilities. Also, when we use those advanced sensors, we realized that we will need some kind of AI to merge information from different sensors and also to process it and interpret them. In this case, we open a new research topic related to the use of AI to merge this kind of information and to perform terrain segmentation and recognition. Also, during our activity, we realized that we could use AI also, for example, to detect samples, to detect not only the sample, but all of the position and its orientation, using, for example, stereo images. And we were working on the use of motion planning to perform manipulation tasks, for example, to pick up a sample, trying to reproduce the sample fetch rover that was going to be sent to Mars in the coming years. But the mission, as you already know, was suspended. And also, we started working on motion planning and trying to analyze how we can improve the locomotion capabilities of the robot to be able to move in challenging terrain or challenging surfaces, joining also motion planning with path planning. Well, going through one of these research topics related to path planning, we started with activity with ESA, the first activity, and trying to provide a multi-layer path planner that merge information. Let's try to play the video. Okay. Trying to merge information from global information, global maps, and also using local maps, trying to merge everything in a common cost map that could be used to perform path planning. In this case, global information could come from orbital images or also from aerial images here on Earth. And in the case of local information, it could be provided through the local digital elevation map that could be generated using RGB images or using stereo images. In this case, you can see the first field test that we carried out at the European Space Agency using the HDPR testbed rover that they have there. And we put some kind of artificial stones that will be detected by the cameras, and we included that information in the global map that you can see on the left side of the media. Well, later on and recently, we used this path planner, part of this path planner in the H 2020 Corro X project. The aim of this project was to explore lava caves and the area surrounding the skylight from the lava cave. In this case, we collaborate with GMB, with the FKI, to provide our guidance and control component that was able to command the robot and to perform path planning, to follow a path to reach a goal position. In this case, it was done in a collaborative way using 3 rovers, as you can see in the video, and doing some kind of scanning the area surrounding the skyline. But also recently, we have been working on how we could improve the path planner for far traverses. In this case, we are working on another activity with ESA, whose main contractor is GMB. And this is the RAPID project, the RAPID activity with ESA. And in this case, we have the prototype of the rover that we will use by the end of July by the end of July in the field test in the Bardenas Desert in the north of Spain, to perform some experiment to see how we can use our path planner to increase autonomy in fast rover, going faster than 1 meter per second, as you can see here in the video. Currently, they are teleoperating the rover, obviously, but the objective is to put our GNC stack within the rover and to try to see if we are able to move the rover in a fast way. Well, moving through the advanced sensor, we get a grant from our regional government to analyze and study how we could use advanced sensor to increase the navigation capability of robots here on Earth, but also in other planets such as Mars. In this case, our initial hypothesis was to use thermal images and to analyze the thermal inertia from the terrain, because we thought that the compactation granularity of the terrain could be retrieved using thermal information, thermal inertia. In this case, we use a facility that we already have at the University of Málaga, with the name is the Martial Chamber. It belongs to the Laser Lab, another research group within the University of Málaga, and it is able to emulate Martian conditions in terms of gases, pressures, and temperature. Our hypothesis was also that if we decrease the pressure, the atmospheric pressure, the thermal inertia will be different. And our preliminary results shown that, for example, in case of low pressure environments such as Mars, the inertia is higher. In that case, it is easier for us to detect different type of terrain using thermal information. Well, also, we have a recent collaboration with the Department of Applied Physics at the University of Málaga. They were able to develop a very compact ellipse instrument, the laser-induced breakdown spectrograph. And in that case, they are able to put the ellipse on board a drone, and it is able to take, to find the chemical composition through the spectrograph from 15-meter distance as the farthest distance. And right now we develop the graphical user interface, and we are going to integrate it in one of our rovers to do some experiment trying to and more time, but okay, trying to get some spectrum to perform some kind of analysis and to see if we can improve the perception of the different terrain using this kind of sensors. Well, related to the use of artificial intelligence, as I already said, we are researching how we can use AI to merge information from different sources, RGB images, distant images, thermal information. Those are our preliminary results, where we can do some kind of terrain segmentation. We are also analyzing what is the impact of each source of information to perform, for example, terrain segmentation. And probably you will see in the coming months a paper related to it from our lab. Also, in the case of the use of AI, we merge everything, AI to detect samples. We merge our guidance and control components, the path planner, and also we include some manipulation component to perform the last phase of the sample fetch rover. Once the rover is between 4 and 5 meters far from the sample, it needs to detect the sample, to go there, and to pick it up. In this case, we use the Exoter rover, the testbed from the European Space Agency. They sent us the rover to Málaga. We have several problems with the heat, with the warm in Málaga, because the experiments were done in June, July, and the temperature was higher than 30 degrees. We need to protect the rover with some kind of cover to reflect the sun radiation and so on. But okay, we were able to do the experiment. You can see in the video that it is a continuous video. There is no interruption. The rover was able to detect the sample using the NavCam, the cam on the top of the mast. And also we were able to detect, once the rover was close to the sample, to detect the sample with the LOCAM, and even to get the position and orientation of the sample to pick it up using the manipulator, as you will see. You can see in the image on the right side, we were able to locate the position and orientation of the sample, and we commanded the manipulator to pick it up. I think it will be in the next second. Now I'm going to pass the video. Could you play the video, please? Okay, doing this experiment, we realized that, for example, in the case of the Exoter rover, it has a 5 degree of freedom manipulator, and we had some troubles trying to pick up the sample, because we are limited in the number of degrees of freedom to put the end effector in the correct orientation. Here you can see the video. Could you move forward, please, David? More forward. Okay. According to the orientation of the sample, using a 5 degree of freedom manipulator in this case, the pose of the end effector is not correct. The best way will be to take the sample from top, orientating in a vertical way the gripper. And in this case, we have problem. Even if you put the sample aligned with the rover, you won't be able to pick it up using a 5 degree of freedom manipulator. For that purpose, could you move forward, please. I will try to go fast. In this case, we include a motion planner that was able not only to generate the path to reach the sample location, but also to generate all the actuator commands to put the manipulator and effector in a correct position and orientation. And in this case, we were able to move the rover and to put the manipulator just aligned with the sample. And in that case, we were able to pick up the sample with any orientation using a motion planner. The motion planner was based on a sequential linear quadratic regulator that is based on the model dynamics and kinematics model of the rover. In that case, we are able also to perform motion planning, trying to increase the performance on the rover, for example, saving energy and so on. What also we use this, okay, the video is working. We use this motion planning in the case to perform MPC to control the Sherpa TT rover, the rover that is holding the cable with the Coyote rover. In this case, it is part of the Corropex. We were controlling not only the manipulator, but also the rover base, the wheels, to compensate forces that was exerted on the manipulator and effector. And in this case, we were controlling the rover. You can see how the rover was moved, the wheel was moved when the speed is higher than the speed that can reach only the manipulator. In the case, we move both them. And also we're collaborating with the FKI on the implementation of the tether subsystem and controlling the tether. Finally, obviously the Coyote rover that you can see there in the image was able to go through the skylight and get into the lava cave as a part of the Corrovex project. Spending some time, but finally it's managed to get inside. Well, finally, related to motion planning, we are also working on how we can go through challenging terrain. We have we started a close collaboration, as I told you, with the Department of Physics, but also at the same time with the Spanish Institute of Geological and Mining Research. They are involved researching the results, the lava case that was generated during the last eruption of the volcano in La Palma Island. And they are proposing us to use a robot to explore those lava caves using the LIP sensor that we already have. And in this case, we are researching this kind of wheels and active spoke wheels that we think that will be suitable to explore this kind of surfaces that are quite challenging. Well, just finishing, related to our activity, from the starting of the lab, we assigned 7 activities, 4 of them with the European Space Agency, 2 of them to H2020 project, and also 1 project from our regional government that allow us to do the research that some of the research I have done. I have much more result, but due to the time limitation, we cannot show you right now. Also related to our academic result, right now we have been supervised HPSD that have been involved in the lab. We have several dissertation work related to master and bachelor students. We also have an internship program for the lab, and we involve master students in between 2 and 4 every year. We have several publications. We have an average of 5 publications every year in journals and also in conference. Well, that's all. I would like to thank to our team in our lab. I think they are most of them, but Raul, for example, that is here, is not here because he was at the European Space Agency at that time. And thank you everyone for attending the presentation.